Happy New Year, everyone. I'm back with the first tutorial of 2014, and this one has a pretty simple result, but unfortunately it's not very simple to do. But if you bear with me, I promise you'll learn at least one trick that'll save you a ton of time with projects like this that have math involved. That's right, if any of you don't like math, you probably will not like this tutorial. There is a bit of math. And there will probably be more math for you because mine actually worked out kind of nice as far as how we are dividing things up, but let me show you what I'm talking about. As I scroll down on this page, keep your eye on the top nav up here. As I scroll down, there is this little pointer that appears, and that little pointer shows what section I'm at. And I've also used anchors on the page to hyperlink these as buttons that bring me to that section, and you can see that the pointer still follows. But really ignore that aspect of it. As I scroll manually, you can see that that pointer corresponds with where I am on the page. And when it's pointing directly at a section, that means I'm directly looking at that section. Makes good sense, right? So how is this happening? This is a simple application of the scroll effects by making an object. This is just a PNG graphic. The pointer itself is just a PNG graphic, and that graphic is moving side to side along with me moving up and down. So that's really easy to do. It's easy to make a graphic move side to side by setting the vertical scroll to 0 and by setting the horizontal scroll to some number. But what is that number, and how do we find out that number? The easiest way to think about this is to think of this as a horizontal representation of the vertical action that's going on the page. As I go down, it goes right. As I go up, it goes left. So that's pretty easy to visualize. And to think about that and to think in that sense, you have to think, well, how does my vertical movement translate into horizontal movement? Meaning, how many pixels down do I have to go for it to move how many pixels right? And in my case, my navigation, or this whole area here, I'm kind of lassoing around it with my cursor, is around 500 pixels from left to right. And when I say from left to right, I'm including where the pointer started, because it starts way over to the left, where it's actually hidden at the moment, but it starts way over here to the left. So this whole area here is about 500 pixels. Now, what's the significance of that? Well, if I know about how wide my whole navigation area is, and I know how tall my whole page is, then I can easily figure out how they divide together. So let me close this up and let me show you guys how tall this page is. I'm going to scroll down, and the top of my last section is at around 5,000 pixels. You can use the ruler over on the left hand side to check that out. So this is around 5,000 pixels, and my navigation is around 500 pixels wide. So if I bust out the calculator and I look at my 500 pixel wide navigation and divide it by my 5,000 pixel web page, that comes out to a simple 0.1. That's how fast my pointer is going to move. It's that easy to figure out how fast the pointer is going to move. So if I wanted my navigation to span 600 pixels instead of 500 pixels, I would just type in 600 divided by the constant and official height of my website. That isn't changing because I already designed it this way. And I get 0.12, so then I could set it to move at 0.12. Now the only problem that you could run into is the spacing between these guys. And to be honest, my example here is the problem that I'm describing. The sections are not of equal size. So even though I've got my start to finish hammered out, the stops along the way are not spaced properly. Because if you look down here at this first anchor that I've created, this anchor is at 2014 pixels. Now it would be really nice if the next one was at 3014 pixels, because then I could just divide that by 0.1 or multiply it by 0.1, and I would have a 100 pixel gap between each icon at the top. It didn't work out like that, unfortunately. If I scroll down and I look at this next anchor here, it's 2969, and if I go to the next one, it's 3929. And they're really not evenly spaced with one another. And the end result was that these icons at the top are not evenly spaced with one another. So how did I figure out how to space these apart? Well, I had to figure out, one, how to space this from this, but also how to space the top of the page, which has no icon representing it, with the first icon, which is the first section here. Now, if you're wondering what the heck I mean by that, I mean the pointer needs to be moving the entire time, right? So if the pointer is going to be moving the entire time, the pointer needs to be moving while we're in this empty space up here before we get to the first section. My first section's not at the top. It's 2,000 pixels down. So step one is figure out where the first stop is, because that's where you're going to start your pointer off. And to figure that out, we've got our point 1 established. We know that point 1 is the right speed for the pointer to move. So now we can look at where this first anchor is. It's at 2014, and we can multiply 2014 by 0.1. So I'll go 2014 times 0.1. That equals 201.4. Now I'm going to have to round it off to 201 because there's no such thing as 0.4 pixels in Adobe Muse, but I know that there are 201 pixels that need to be between where this starts and the first stop, because that's how many pixels between the top of the page and the first stop vertically. So I'm going to slide this guy over and line it up with my first stopping point, and it looks like that's an X position of 588. That's not where I want it to start. I need it to start at 588 minus 201. I need to back it on up by 201 pixels. So here's my favorite trick that I learned in this process that really cuts out a lot of calculator work. You can just type in 588, which is already there, minus 201 in my case. Your math will be different. And when I hit return, it automatically moves it over. That's right, Adobe Muse does math. It's built in to the transform panel of Adobe Muse. You can actually type in plus, minus. I believe you can multiply and divide as well, but in this case we're just going to be working with plus and minus. So by moving this over 201 pixels, it is now 0.1 of the gap between the top of the page and this first section. And this again is a horizontal representation at 0.1 scale of the top of the page to the first section of the page. So then this next one, this gap here, is going to be 0.1 of the difference between this first section here, the welcome section, and this second section here, the gift of feeling pretty is the name of this section. So I do need to figure out how far apart those are from one another. So I'm going to take a look at this anchor. It's at 2014, and I'm going to take a look at this anchor. It's 2969. So I'm going to bust out the calculator and do 2014 minus, I already forgot what it was, minus 2969. So I'm going to come back here, minus 2969. And it looks like they're 955 pixels apart. Now that's how far apart they are vertically. Now let's multiply that by 0.1 to figure out how far apart the icons at the top need to be. 95.5. So again, we're not really able to use half a pixel, so we got to round it. So if I need to know how far over this needs to be, now I know, 95.5 pixels. So I'm going to line this up with the center of this icon. It should kind of snap into place. And then I'll go over to my X value here, and I will add that, how much was it? 95.5, let's say 96. So I'm going to add the 96 pixels to the right, and boom, it jumps over 96 pixels to the right. So I'll do the same with this one. I'll figure out the difference in the height of the two sections, and I'll multiply that difference by 0.1, because that's our horizontal scrolling speed for this pointer, and I'll nudge it over by that amount by popping that math into the X box here. No pun intended with the Xbox thing. Not that that's really a pun, because we're not talking about video games. But the point is, this guy needs to start to the left in my case, and it needs to hit on these points by virtue of them being in the right place. Not by virtue of this stopping in the right place, because this thing doesn't stop. It just goes along the whole time. So these need to be in the right place. This needs to start far enough to the left, and all of that math is based on the speed being multiplied into the y coordinates of each of our stops along the way, if that makes any sense. And again, if this doesn't make sense, watch this over and over again. Go back to the beginning, because at the beginning we talked about how we even arrived at 0.1 in the first place, and we kind of blazed through that, so feel free to go back. Now this guy here is showing. If I preview this, it's over here pointing at nothing. It's pointing at absolutely nothing. And as I scroll down, it's moving, it's moving, it's moving, and boom, it does eventually line up in the right place. but it starts off pointing at nothing, which is why I created this box here. And you'll notice that this box has a little T handle coming off of it, and that's because all of these things, again, don't forget, all of these elements that are part of the header need to be set with scroll motion, or scroll effects, with the motion set to 0, 0, 0, okay? They need to not move. They're going to move only vertically. They're not going to move horizontally. So I'm going to position this guy back on top to hide my pointer. And when I use it to hide my pointer, this T should be at the very top here because your key position for everything is going to be 0. Remember, 0 is all the way down. And now when I preview it again, in previewing it again, my little pointer is hidden until it gets to about here. And then it looks like it fades in, but really it's just that gradient that's that it's popping out from under. So this box, if you guys aren't sure how I made this box, this is just a regular rectangle, and I used the fill in gradient mode to go from the color of the bar at the top to the color of the bar at the top. So it's the same color for both, but then opacity is set to 0 for the right-hand side, and it's horizontal, of course, not vertical. If it were vertical, it would look like this, which does not look right. So that's got to be set on horizontal, and this is left to right. So left, it's 100% opacity of the color of the header bar, and right, it's 0% opacity, but also the color of the header bar, and it's on top. So if yours isn't going on top of the pointer, then you'll want to change the order of things in your layers to make that go on top. So with that on top, and with everything set to a vertical scroll speed of 0, you should be a-okay. I'm just double checking that everything is zeros down the board, and oh, looks like we have a 1 in there on accident. That should be a 0. Everything should be zeros except the pointer itself. The pointer itself is the only thing that has any horizontal scroll to it. Everything else zeros down the board, and again, don't forget the key position set at 0. And the reason for that, if you guys haven't done any sort of frozen elements using scroll motion, the key position is how far from the top the frozen element will be. So if I have this in the wrong place, say I have it down like this, when I go to preview it, that's how far down it'll be from the top. So it's actually up here now because I compressed the little T handle. Now that little T handle needs to be at the top, and that goes for all of these elements, including the bar itself. Don't forget the bar itself. The bar itself, mine personally, is set to be 100% page width, and if you're not familiar with that, that just means it goes all the way to the edge, all the way to the very edge there. And that is the reason that when you look at the scroll motion, that the horizontal is grayed out. Whenever you have a box set to 100% page width, it can't scroll side to side because it's locked at the full width of the page. So I understand if you need to watch this tutorial more than once. I had to record it more than once. It's honestly the most difficult tutorial that I have recorded so far, and I would not be surprised if it is the most difficult to follow. But again, just think of this navigation at the top as being a horizontal representation of the vertical space of the page. It's just miniaturized and it's sideways, and you need to figure out how miniaturized. And again, that was toward the beginning of the tutorial. In my case, it's exactly 0.1. It's 10% from left to right as my page is from top to bottom. So hopefully your page is around 5,000 pixels tall too, because then you can just use that 0.1 multiplier. But if this ends up being a quarter of the width of your page, then 0.25. If it ends up being half the width of your entire page, then 0.5. So the math isn't completely outlandish. It is just a pain. So sorry for the little lecture at the end trying to console you guys. I almost feel bad at the end of this tutorial because there's so much math and it's really just not nearly as fun as the other tutorials. But I hope you guys enjoyed it. I hope you at least enjoy the end result, and I hope for sure that you enjoy the fact that on the transform panel you can type in mathematical equations, at least addition and subtraction. I haven't really dug deep into that. So bookmark this if you need to watch it over and over again, and don't forget to check out museresources.com where you can download all kinds of Muse library files that I've published for you guys. All this stuff is free. And if you haven't checked it out yet, then check it out now. And if you haven't subscribed, please subscribe. I really appreciate the fact that I just reached 4,000 subscribers. So that's super exciting. Good way to start the new year. So Alright guys, hopefully the next one is going to be more fun. It actually will be. I've actually already got it lined up. I've got my demo created and everything. So the next tutorial will be a fun one, I promise, and a whole lot easier than this one.